This will be an interactive session, so please feel free to stop me anytime and ask questions if you don't get anything. I'll be presenting in this flow. Like first I'll introduce to the scientific illustration, then what is the workflow of your figures, what should be the ideal workflow. Then I will introduce you to the different tools for figure creation. Then as this generation is proceeding to AI, then use of AI, how we should use it to create figures, and some journal specific requirements for figures, which are mostly common in all publication types. So what are scientific illustrations? If we see that all scientific illustrations in review, or if you see any research hypothesis, they simplify such biomedical concepts so that the figures can visually communicate with the reader. It enhances the engagement of the reader, and they help to convey mechanism in a simplified way so that even a common person can understand what is the scheme of the article, what is the main purpose of the article, and by just referring to a figure. So figure should be created in such a way that you can observe it in one glance and get the gist of it. As scientists ourselves, we can understand complex things also, but whoever is starting with this concept, and master student maybe then bachelor student, if you see, they can understand through these illustrations better. So general workflow for creating scientific illustration. First, you have to understand the scientific concept. You have to refer to much literature for writing reviews as well as for the creating figures. Then, creating a rough layout for the figures always helps before you start creating it digitally. So, it's my practice that I use a scheme in my a note and a pen, and create a rough layout of how I want to present my figure. You determine if it is a mechanistic figure, a graphical abstract, or a workflow process, either experimental design. Pharmacology students can relate with the experimental design, like we have how many days of the induction, then how many days of therapy. So all that, if you create first on a rough sketch, then it is easy to make a digital figure afterwards. So it's my practice. It depends on individual, but it's my practice to create a rough layout. Then I collect the scientific components which are required for my figures. So everybody does not have access to all the paid tools available for creating figures. So we can collect scientific components from many freely available software, PPTs, and icons. So I have a practice to collect all those and create a separate presentation of my commonly used templates, which helps me every time when I create a figure. I don't have to look for it again and again. So, and then we can select an appropriate software. If you have access to a paid software, you can use that. And lastly, you have to export it in a publication ready format. So each journal has a definitive guidelines in which format they require the figure. So you have to refer that first before exporting it, and then you can export in any format you like according to the journal requirements. Basic principles of effective scientific figure design. So clarity, accuracy, consistency, logical flow, and readability are most important principles for creation of any figure. The figure should not be overcrowded or anything. It should be clear. The message should be clear. Then accuracy is the most important thing, I think. When you do a literature search, you always have to have a reference for everything you are presenting in a review or research, everything you are citing. Same goes for figures. If you are describing a mechanism, you should have cross-checked it with a accurate, scientifically published reference. So that is that. And consistency, like in every figure, you should maintain uniform fonts, colors, formatting. It should not look like a jumbled layout. It should look like a proper scientific illustration so that it is uniform and consistent throughout. And not for one figure. If you are making like 6 figures for a publication, ensure that all the 6 figures have same type of fonts. So if you use different type of fonts and anything in all different figures, that it creates a bad impression on the editor or in the reviewer. So try to maintain that consistency, uniform fonts, colors, formatting, and arrange your content in a logical flow. That's what goes after creating a rough layout. Check whether it is logical or not, and then proceed to create it in a easy to understand flow, and it should be readable. So I suggest you use simple fonts like Calibri, Helvetica, Arial, but not like very bold. Arial Black, don't use Arial Black. So this should be, the fonts should be very understandable and clear. Like this is the Calibri font. It is understandable. It is not jumble. If you use some cursive type of fonts, the figures might not be legible to someone. So always use a practice to use this type of font. These are some common mistakes people do while creating figures. They add too many elements in the figure so that it becomes overcrowded, which is not understandable. You should not use low resolution images. When exporting a figure, you should take care that the resolution is at least 300 dpi. Inconsistent formatting, like I said, don't use different colors, fonts, arrow styles in a figure layouts in the same figure. You use it consistently. Then improper labeling. If you have created a graph for a research paper or anything, there is small things you should check, like the label axis is same color, same font, same annotations. They are like the font size is same throughout the graph. You should check all these small things, otherwise it makes a bad impression on the editor or reviewer. And do not use distorted scales. Like in one, suppose you are preparing graphs, so in one graph you have used minor text, and one graph you use major text. One you have used it outwards, in one you have used it inwards. So this doesn't look nice, and it is not visually very appealing. So try to see that every figure has same type of access labels, same type of graphs, access fonts, everything. So avoid the misleading data presentation. This is one figure from my review. The left side is the correct representation, and here it's the incorrect representation. So if you see, the correct one has all the fonts of the same manner, same size, and the arrows are consistently used. Whereas in this, if you can see, this font is different. This type of font should not be used. Uh, this font is different and the arrow is different. So you should make the figure such a way that all styles and everything is very consistent and it looks visually appealing. Now, moving to advanced tools for creating scientific and medical illustrations. First one is BioRender. Many of you might be aware of this platform. It is very widely used for creating professional, biomedical, and life science figure. It has certain advantages, like you can directly search, drag and drop scientific icons. It has a huge library. You can collaboratively make figures. It can be exported in many formats, and it has some general style templates also. But this platform is paid. If you don't have the idea of how to use this BioRender, I can briefly show you. So this is the BioRender illustration. This is the free trial version. So it might not give access to everything, but if you see, these are the ready-made templates. So you can use this template and change some elements according to you, change colors, and make a figure in a very short time. If you need some mechanism or anything, like this is a cell membrane figure, so you can directly use it and edit according to you, or you can make a new figure by searching here the icons. There are many icons. There is a huge library, so you can always search here. And now there is a AI feature also, which allows you to generate tools, generate figures using AI tools, and there are some basic lines, arrows, everything. So it is actually really nice tool to do a figure, but only catches it is paid, and you have this watermark appearing, which should not be in the publication, and you cannot use BioRender publication without its publication license, uh, because it only you can only use it if it is a paid version. So you can use BioRender figure for your presentations, for your maybe thesis or internal figures, but you cannot use it for publication until you have a publication license. So these are some of the figures I made with BioRender. I briefly had access to a paid version of BioRender. So I had access to all the templates and all the icons. So I can show you, this is the different type of figures you can make. This is the pathogenesis figure I have made using BioRender. I have used Parkinson disease cellular mechanism using the BioRender. So you can see all different type of elements I can use, and I have made a pathogenesis figure. Similarly, in pharmacology, you have this experimental design figures. So all this is available. All these templates are available in the BioRender, and you can make it this figure in like 1 to 2 hours, because you have mostly access to all this icons and everything freely in the paid version. You can make Sutix based figure like drug delivery figures, then cell signaling and mechanisms. These are all figures from my review and research article which I have made using BioRender. So, does anyone have any questions up till now? If not, then I'll proceed. So, only difference between the free version and the paid version. In free version, you get very limited templates. You cannot edit the templates. Then you have watermark. You limited illustration you can create and limited downloads. Only basic editing is possible and no publication license. Where in the fully paid version, you have all the access to the library, no watermark, unlimited downloads, fully editable figures. So in this case, if your university has a subscription of BioRender, you should check it out. So there are university-based uh, subscription. So that's what I used previously. So in that, many users can access it through a single account. So that is very like very advantageous, and you can refer to your university for creating the figure if it is possible. So, just for your information, this is the kind of publication license you get in BioRender. So it was for a figure. I used so this is the figure name. This cancer P. It's abbreviated figure name. I had created in BioRender. You have to elaborate these things like publisher name, which in which you are going to publish. If you know the journal, you can mention the journal name also, and it gives you this type of document which allows you to use their figures in a publication, and then you have to cite it. This citation can be used to cite the figures, and also you have to mention in the acknowledgement section that you have created this figure in BioRender, and you have to upload this publication license along with the files you upload in the journal for the manuscript. Second platform is Canva. It is a very general graphic design platform, and it used in scientific communication as well as medical writing. It has many template icons, and you can prepare wide variety of things using this Canva. Conference poster, infographics, graphical abstract, presentations, slides, medical visual, and flyers and everything. Uh, there are some limited uh, features you can use in Canva. See, this is Canva, and there is a blank project I have opened here. So this is the different type of elements you can use. You can even search your elements. Uh, like research, if you search it, that you get different elements. So this is very ideal to prepare a schematic, infographic, or a graphical abstract. Maybe all the scientific elements you might not find exactly here, and some are watermark figures. So you have to take care while using that. So this platform is actually new, and you can borrow many icons from here. There are many templates also you can use to generate your infographics or graphical abstract. So these are ready-made templates and you can edit them. You just have to check this one symbol. If it is premium, then you can't use it. If it is free, you can use it freely for your publication or film creation. So these two things I have created, like example of this flyer poster I have created entirely using Canva. All the free elements and everything I have used Canva to create this flyer, and mainly you can use it to create the poster presentation templates. In if you ever go to present in a conference, there are many templates for a scientific poster, so you can use Canva to make these figures. Also, there is a comparison between the free and the paid version. Same thing, basic templates, appearance of watermarks, limited images, limited AI features, and less storage. In paid version, you get access to almost everything. So this is the hello.
Yeah, sorry to interrupt. Actually, we have one or two questions regarding that BioRender. I think we can clear those questions over here itself.
Yes, sure.
So one question is, Akirti Rai is asking, ma'am, in BioRender we can use 50 icon only in free version, or what should I do next after using 50 icons?
Okay, so in BioRender, you can use only 50 icons. Here there is the limit, but you can obviously not use any of the templates for the publication without disclosing it. So I suggest one simple trick. If you want to use it for your internal figures, like you can copy paste the figures in blank PowerPoint presentation and like delete it from here. So if you get a screenshot of this icon, then you can use it in a blank PowerPoint presentation here. Suppose I.
So Ritu, in this case, there will be no copyright issue or something else?
You cannot use it for the external publication images because it will be now the BioRender images are actually screened very tightly. So I would advise not to use it like that in publication without license. But if you want it for your internal use, maybe you are presenting somewhere or in meetings or anything, or in thesis also, some figures can be created because here there is a limit. Previously there was no limit, so we used to create figures and export it for our internal use. But now there is a limit, so you cannot freely even create the figures here. So this trick can be used to make the figure like you desire, and then you can recreate using free tools. You can recreate you finding by finding same icon. Once you have the digital figure ready, you can always recreate it. But I advise it not to use it for any publication without the publication license, because um, once I had prepared using the paid version only, and I have not uploaded the publication license. The journal has specifically asked me to upload the publication license for BioRender. Luckily, I had that time the paid one, so I immediately uploaded it. But if you're using any template and it gets flagged out after peer review, you will be losing a lot of time, and the publication will be ultimately rejected. So I advise not to use it for publication figure without the license. But internally, if you want to create first using all the templates, I have shown you this trick. You can use it and use it for your internal purposes.
Okay, and one more thing, I think resolution should also be reduced in case while we copy or crop these image and paste into the PowerPoint. So is there any solution to this, like enhance the quality or enhance the resolution or DPI?
Yes, you can always enhance the DPI. There are freely available like online sources, free links to increase the resolution image, or else you can always use Paint to Microsoft Paint to enhance the resolution. If you resize the figures in MS Paint, automatically the resolution will change. So you can use that, or the online freely available links to, but in the online links, I will just say that if you have very confidential figure, do not use the online options. Use Microsoft Paint or Adobe. If you have access to Adobe, you can always use Adobe to increase the resolution of figures.
Okay.
Dr. Ritu, how much charges we have to pay to buy this particular software or tools for one month, 1 year, and 6 months?
So, see, initially you have some free trial, but there are many payment plans in BioRender. So, personal use, there are many options like for personal use, for university purposes, for institution, and for a lab. So, these are the publication plans available here. So, I think this will be very costly if you try to use personal, individual, everything. I suggest your institution if it can get the license. So this is very beneficial because multiple user of the institution can use this. If the university can get this license, and it will be very helpful.
Okay.
Okay, so this is the ChemBioDraw Ultra. It is a very specialized software which is mainly used for chemical structure and reaction schemes. So you can make chemical structure, reaction pathways, synthetic chem, even molecular figures, and some biological elements are also in this. In ChemDraw, this is ChemBioDraw. In ChemDraw, you have only chemical structure. So for biological structure, you have to have the ChemBioDraw. So I will show you quickly how to. So this is the ChemBioDraw interface. It is a software which you can install it in your PC. For 1 month, you get a free trial of it, and after that, you need to purchase license. In this, you can simply draw structure by entering its name. Suppose I have entered a drug name. So it will quickly get me the structure of the same drug which I have entered. So by this, you can draw structure using ACX name, the ACX number, then the name. You can easily like import structures here. So because in research publications or review publications, if you're mentioning the structure or inserting a figure of the structure, you cannot directly use PubMed figures for it. You have to draw a structure. If you're using any new drug also, you need to draw a structure. So in that, you have many different elements which you can use to draw structure according to your liking. Here are like the benzene ring and everything. And here are the biological elements you can use. So these are many biological elements, chains, anatomical figures, instruments. So this software also gives a wide range of templates. So you can use this software also to prepare your chemical schemes, biological schemes, structures, everything. So this is also a very useful software. So for 1 month you have this trial, but you have to like disclose it when you are using any tool for figure generation. You have to disclose it in the acknowledgement section that you have used a specific tool for figure creation. Now, AI-based illustration tools. So, as you all know that AI is now widely used, and AI can help you generate figures very easily. So, these are some of the common AI tools we use in the medical writing in our company. It is ChatGPT, then we have the Genie AI. So, we have the paid version of the Genie AI, then Perplexity, Gemini is there, and Adobe Firefly. So, for figures, these are the common use like figure concept generation, flowchart drafting, generation of scientific icons, and then we recreate those figures using PowerPoint, or we get like figures under some license which we can use for publication. So I'll show you how to. So before using AI generated images, you check that if it is free for commercial use, allowed for journal publication, it is editable or restricted, it is watermarked or not, and most important thing, you have to check the scientific accuracy of the figure and identify any discrepancies in the figure. So we had suppose I had a project on medical writing. So we generate a figure using AI, and we mention that to the author that we have used it using AI, and we will recreate it after the finalization of figure. So for concept approval, we generate AI figures and then recreate it. Uh, while recreating also, we can use certain elements or icons from the AI based platform, but we have to ensure that the Creative Commons license and all these things, like it should be royalty free. We can use it without any kind of payment. Then most important thing, you have to check the CC license in the figure you have used. I'll explain you what is it. Then the commercial license, if it is allowed for publication of use and editorial use only. And when you have used such a figure in your publication, you have to mention disclosure of AI. Also, when you have used the CC license, you have to mention it in the acknowledgement section that image has been reused under the Creative Commons license. So this is very mandatory. You have to consider it while publication, because if it is flagged, that it builds a bad reputation for you. So this is very detailed thing. I will not get much into it, but there is a Creative Commons license for each figure. So CC BY license and CC 0 license are mostly, you can freely use them and recreate figures or use any icon element from them. So um, but the attribution is required. For CC0, you don't even require the attribution. Like you don't have even have to mention it that you have used something, you have used something recreated or anything. It is in public domain, so it is completely free to use without any attribution. But CC-BY license is the license which most open access figures have. So in that you can use it for publication, modification and recreation is allowed, and but you have to give a specific attribution, like you have to put a line that it is used in the CC-BY license. And these are the different type of license. For subscription, like any journal has a subscription based publication policy and everything. So these are different licenses according to this. So this is a whole different concept. I will not get much into it now because it's a very detailed thing, but for figure generation, you have to remember that CC-BY and CC0 license can be used for recreating figures. So example of the AI prompt, like these are the different type of schematic figures you can use. This is graphical abstract, mechanism of action, drug delivery pathway, any clinical trial like consort style clinical flowchart, infographic or disease pathogenesis, experimental design. These are all the type of figure you can create using AI, and these are the example prompts of the figures. So many of you might not be knowing what is a consort style clinical trial flowchart or anything. But if you refer to a clinical manuscript, you have like a flow diagram of how many patients were screened and how many patients were included. That is a consort type flowchart. For that, I think you don't have to have a specific license to use, but the AI just uh, puts boxes and recreates the flowchart for you. So this is mostly safe to use without anything because it does not include any elements or any icons. But for all other type of figure, you have to check the license. So I'll show you what AI created with a prompt. So I have used the first prompt, and this figure AI has created. So if you see, it's a very detailed figure. So this was my prompt, that create a professional graphical abstract showing nanoparticle mediated delivery of miRNA across blood-brain barrier for Alzheimer's disease therapy. And this is the figure it has created. So it has described the nanoparticle system, the systemic administration, then crossing the blood-brain barrier, miRNA action, and therapeutic outcome. So visually this figure looks very appealing, but the things you have to check before you use this figure. First is the license, then second is the disclosure, then third and the most important is scientific accuracy and the discrepancy. So if you are using this as a nanoparticle symbol, to ensure that this icon can be used for representing nanoparticles, then you used all these components for describing the nanoparticle system. So you check that if pagylation is used for nanoparticle or not, if transparent is used or not, if these two are used in combination or not. So you have to check the scientific accuracy of the figure. Like uh, a common person cannot tell what are the discrepancy, but if you are studying this topic, you will immediately know that many discrepancies are there in the figure. So when you use AI to create a figure, you have to make sure that it is accurate, and if you want to change anything, you have to keep giving repeated prompts to it. So I would only advise that you use AI to for concept generation, not use to create entire figure by itself, because it might lead to many inaccurate elements or inaccurate information be used in your publication. So always make a habit of creating the concept and then recreating the figures. So these are some additional tools which are free to use, like MS PowerPoint. You can use many icons are there. Adobe Illustrator. It is a some parts are free, some parts are paid. Then graphic figures is mostly for research articles. It is used to create different type of graphs, or it has different type of options for analysis also. Then Microsoft Excel have for basic graphs you can create it. Image J is for image analysis of histopathological slides or any Western blot figure. You can use it. And lastly, this is the I think very important for us. Servier Medical Art is a freely available online PPT template which we can use in PowerPoint. So this is a figure I have created using the Servier Medical Art, and it is freely used. Like in this, on the site, if you go, you can get around 3000 free medical images for creating illustrations. So I will show you. This is the smart PPT. All the PPTs I have gotten from the site. It has different type of therapeutic area and different type of presentation. So there are many freely icons like BioRender, but in difference of BioRender, these are absolutely free to use. You just have to mention that you created using Servier in PowerPoint and acknowledgement. But these all icons are freely available to use. So this is very important for creating review figures. You can use all these icons. This is the neurology template, but there are many templates referring to many other TAs and many other fields which you can freely use to create figures. So this is my review figure, which I have recreated without the use of BioRender completely in the PowerPoint. So this kind of figure you can make with the Servier Medical Arts. You can download it from this site. So this is the link. You can download the free templates from here. And lastly, these are the tips for to improve clarity, readability, and generic content. First, improve clarity and readability. Always keep fonts greater than 8 to 10, not smaller than that. Then follow journal guidelines. First, see in which format you require the figure and export in the same format and the resolution requirements. I suggest you keep at least the resolution 300 dpi. If the journal requires more than that, then you have to change it. But keep it 300 dpi minimum. Then maintain consistent formatting, same font. But here I'll show you a trick. If you use similar colors, you will not get idea that suppose I have used to fill this. Okay? So I have used this color and this color. So I will not get idea that these two are different colors. So what I suggest is for checking it, you use the hex code. So for every color, when you go to more option, there is a hex code. So I suggest you refer to the hex code for colors for uniformity. So every different color will have a different hex code. So that way you can maintain the uniformity of the colors in your figures. Like this is the color hex code for automatic, that is black. And pixel dimension. You can always resize figure using the MS Paint, Photoshop, Canva, or Image, and avoid stretching figures unnecessarily as it reduces quality and pixelation. So thank you for your time, and please be interactive and ask as many questions as you want.